Okay, hi y'all. Today we are looking at solving polynomial inequalities. And there are two sections. There are the graphs, and then there is the equations, or the inequalities themselves. So we begin with the graphs. Let's say we have a graph of a polynomial right here. Polynomials are smooth functions, so they rise and fall very easily. Let's give this one a name, f of x, and let's go ahead and solve. When is f of x right here greater than or equal to 0? Well, for a function to be greater than or equal to 0, this means that it needs to be above the x-axis. Now, we need some information. We need to first identify some key points. The x-intercepts. This first one, it says -3, 1, and 4. I like to think of the x-intercepts as points of transition. That's where the graph goes from one side to the other side of the x-axis. When you're above the x-axis, you are greater than 0. When you're below the x-axis, you're less than 0. And so very simply, a point of a transition is where all the action happens. And so I want to know when this thing is greater than 0, above the x-axis. And because of the equal sign, I'm using closed circles. Well, at this one right here, it starts going above. And then up until 1, it is above the x-axis. So closed circle at 3, closed circle at -3, closed circle at 1, and then we shade in between the areas. But this is not the only time the graph is above. If you look over here, closed circle right here, and then I shade off in this direction forever. And so there are two areas, two intervals over which the graph is greater than 0. And so my solution will be square bracket -3 to 1 union 4 to infinity. And that would be the solution to my question right there. Next, we have an example that looks like this. So, and then the graph of my function looks like this. It just touches, and then it comes back down. This graph only has two x-intercepts. One is at -3, and the other one is at 2. And I have two questions for you. When is f of x greater than 0? And when is f of x greater than or equal to 0? They look like the same question, right? So the answer should be almost the same, right? Well, let's find out. So, let's do this one first. Greater than 0 means that the graph must be above the x-axis. It cannot be on the x-axis. So at 3 right here, I will have an open circle. And then I will go ahead and on this side right here, on the left side, the graph is above the x-axis, right? So I shade forever in this direction. And then between 3 and 2, again, open circle at 2, the graph is above the x-axis. And so my solution would be, for this question right here, -infinity to -3 union -3 to 2. There's a break at 3 because of the open circle. On the other hand, when I am solving the equation with the equal to, the graph looks essentially the same. The difference is I will now have a closed circle here and a closed circle right here, because it's allowable for us to be on the x-axis, to be equal to the x-axis. Again, above the x-axis, so shade. Again, above the x-axis. So again, the graph is above, see, above the x-axis. Over here it's below, so we don't want that piece. And so my answer is actually quite different. Notice that I'm shading all the way through. So my answer is simply -infinity to 2 square bracket. And that, my friends, is the solution to all our problems. Because, you know, we ain't got no problems. Graphs, that's about it when it comes to graphs. You just got to be careful and look at the graph carefully. On the other hand, when we have an equation, we will solve them by using the sign chart method that we've been using before. So take, for instance, this problem right here, solve, and then I want to know when x plus 2 times x minus 3 times x plus 5 times x minus 7 is greater than or equal to 0. Well, the first thing right here, I am going to need my zeros, because my zeros are my points of transition. The zeros will be when the graph shifts from one area to the next, from either above or below to the other area. And so, find my zeros, again, which are my transition points, and then -2, 3, -5, and 7. And I simply place those on the number line. And, well, it's the number line, so the first is going to be -5, followed by -2, followed by 3, followed by 7. And then I ask myself the simple question: if I cut a string 4 times, how many pieces do I get? And the answer is 5. The first region will run from -infinity to -5. I will use a square bracket because of the equal sign. Then -5 to -2, then -2 to 3, then 3 to 7, then 7 to infinity and beyond. I then need to test each of these regions to see if it's true or not. Is it greater than 0? The easiest number to test for me, I believe, is 0. And 0 is in this region right here, a test point of 0. So that means I'm going to take 0, plug it into the function, and see if the sign is true. Will my answer be greater than 0? Well, that shouldn't be that bad. If I plug in 0, I will get, let's make some room, plug in 0, I will get 0 plus x plus 2, so a test point of 0, multiplied by 0 minus 3, multiplied by 0 plus 5, multiplied by 0 minus 7. And that is 2 multiplied by -3, multiplied by 5, multiplied by -7. And I want to know, is this greater than or equal to 0? Now, I'm not going to actually multiply these things out. I got better things to do with my life. All I care about is my answer, positive or negative. Positive means I'm above the x-axis. Negative means I'm below. Well, a positive times a negative times a positive times a negative is equal to a positive number. A positive number is greater than 0. And so therefore this region will, you can either write a plus or a check mark. It really doesn't matter to me. But this right here is one of our regions. The nice thing is we don't need to check any of the other regions. And that's simply because we know that our points transition, and so therefore the graph will go the other side with each of these transitions. There is one caveat to that which we will discuss in a second. But for now, with this basic function right here, this will be a no and this will be a yes. This will be a no and this will be a yes. And so I have 3 check marks, and so that's enough to give me my solution. The solution to my problem, because I have no problem, my solution will be from -infinity to -5, union -2 to 3, union 7 to infinity. And that's the answer to my problem right there. No worries, no problems. Alright, so like I was saying, well, these things change nice, right? Alternate, 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 alternate. Well, how do I know that they're alternating as opposed to not alternating? And let's look at an example and let's explain. Let's say I have this problem right here. I want to solve the inequality of x minus 2 squared times x plus 4 times x minus 5 squared times x minus 3. And I want to know when this is less than 0. Let's make our life easy, right? What you would notice right here is that unlike in the previous example, I have an even power here and I have an even power here. The rule is, whenever you have an even power, you don't transition. The sign stays the same. That's the only thing you need to remember. So let's go ahead and put all of this into action and let's see how this rule plays out in helping us solve the problem. But what we care about is the even powers. Watch out. Forget I spelled house. Watch out. Oh, forget I spelled out. My bad. So, let's roll. I gotta find my zeros. And that is a 2, negative 4, a 5, and a 3. So I have my number line. And I have negative 4. It's a number line, so we're going in order. 3 and 5 right here. And what I'm going to do right here is that I'm going to write in the letter E for the 2 right here, because this right here is even. As you go along, you learn that that power is the multiplicity. We'll get that some good day. But this right here has an even, so we have to treat it differently. And then the 5 is also even, so we have to treat that differently. So I have 1, 2, 3, 4 zeros. So if I cut a number line 4 times, how many pieces will I get? Someone said 5 and they would have been right. And I have no equal sign right here, and so my regions will be negative infinity to negative 4. And then I have negative 4 to 2. Then I have 2 to 3. Then I have 3 to 5. Oh my goodness, how many intervals do we have? And then I have 5 to infinity. And so, with this right here, I gotta give myself a test point. Which one of these has 0 in them? It looks like this one right here will have a test point of 0. Again, 0 is normally just the easiest test point to use. Get whether it's true or not, and then we can go from there. So I'm plugging in 0, and so that's going to be 0 minus 2 squared times 0 plus 4 times 0 minus 5 squared times 0 minus 3. And I want to know, is this negative? Is this going to be less than 0? Well, 0 minus 2 is negative 2. Negative 2 squared is positive, so this is positive. 0 plus 4 is positive, and so that's positive. Negative 5 squared is 25, that's positive. And then negative 0 minus 3 is negative. So a positive times a positive times a negative will be a negative number. So this is true. So this whole thing equals negative, and so therefore that's true. This is less than 0. And so therefore this region right here will be a check mark. Now, here we go. If we don't have an even symbol, the sign changes. So this is wrong. Right here, check mark, I have an even, so it stays the same. I don't have a symbol right here, and so that changes. Again, I have an even right here, so it changes right here. And this right here is my answer. My solution is those 2 check marks. Okay? So the entire difference in the entire problem is that, remember, when you have an even, the 2 regions next to each other will always be the same result. Will always have the same sign. And so my solution to my problems is I ain't got no problems. My solution will be negative 4 to 2 union 2 to 3. And only in those 2 regions will my function right here be less than 0. In the remaining places, it will be greater than 0. Sometimes we like to be mean to you, and then we give you a problem that the zeros are obvious. And so your first goal is to work to find those zeros. And once you found those zeros, you can go ahead and complete the rest of the problem. So let's say I have right here 2x cubed is greater than or equal to negative 16x squared. And I need to solve this thing right here. Well, I take the 16x over, 2x cubed minus 16x squared is greater than or equal to 0. I factor. Well, I see they have a 2 in common, and I see they have an x squared in common. And so I factor those out. So that is going to be 2x squared, open parentheses, and that's going to be x minus 8 is greater than or equal to 0. Now, notice right here I have an even power. Again, it could have been a 4, it could have been a 6. All I care about the power is even. Notice over here the power is odd. A 1, a 3, or 5. Odd powers behave exactly the same. Even powers behave exactly the same. And so, with that right here, my zeros are 0 from this one right here and 8. Those go onto the number line, and I go from there. So I get my number line. Somewhere in my number line is 0. Somewhere on my number line is 8. The 0 comes from an even power, so I put a little e right here to remind me that this thing is even, the power is even, and so the sign doesn't change. The sign on each side will be exactly the same. Now, if I cut a number line twice, I will have 2 pieces. The first piece will be negative infinity to 0, and then 0 to 8. The second piece will be from 8 to infinity. And now, I'm ready to test. Well, normally I test with 0, but I can't because 0 is a boundary value. Right here, 0 is a boundary value. And so let's go ahead and use a different value. Let's go ahead and use 1. So I'll use a test point of 1. So I will go ahead and go TP1, and I'll plug 1 into the equation and check to see if it's true. If it's true, it gets a check mark. If it's not true, then get a big ol' X. And so this is going to be 2 times 1 squared multiplied by x minus, multiplied by 1 minus 8. This first piece right here is positive. 1 minus 8 is negative 7, and so that's negative. So I'm multiplying. A positive times a negative is negative. And they want to know when this is greater than or equal to 0. Well, a negative number is not. N-O-T, not greater than 0. And so therefore I will have an x right here. There is no e right here, and so therefore I transition to the other side of the equation, so that's a check. There's an e right here, and so therefore this is also going to be wrong. So now that I have my checks and my x's, I can go ahead and solve my equation. My solution is that from 8 to infinity only, the graph is going to be greater than or equal to 0. Alright, thank you. Well, have a nice day.